At 2:17 a.m., deep beneath Earth's surface, something moved. Not a tremor, not a quake. Something else. In a quiet control room filled with softly blinking monitors, a single line of data began to shift. At first it was subtle, almost invisible. A slight deviation. A ripple where there should have been silence. The automated system flagged it, labelled it routine noise, and kept recording. Then another sensor reacted, and another, and another. Within seconds, monitoring stations across different continents registered the same disturbance. Alaska, Iceland, Japan, Chile. Signals arriving within milliseconds of each other, perfectly synchronized, as if something vast had stirred beneath the planet all at once. Technicians leaned closer to their screens. Coffee cups paused halfway to lips. Fingers hovered over keyboards. The data didn't look like seismic waves. There were no sharp spikes, no violent signatures. Instead, the pattern rolled slowly, steadily, like pressure shifting through something massive and deep. A software alert chimed. Anomaly detected. At first, they assumed it was a glitch. Instruments fail, satellites misread, servers desync. It happens. Protocol demanded verification, so engineers recalibrated sensors, reran diagnostics, cross-checked timestamps. Everything came back clean. The signal was real. Across secure lines, labs began contacting each other. Short messages, precise language, no speculation. Are you seeing this? Confirming identical waveform. Depth estimate pending. Silence hung between replies, because the numbers didn't make sense. The disturbance wasn't near the crust where earthquakes form. It wasn't in the upper mantle where magma shifts. It was far deeper, so deep that movement there should be almost impossible. Pressure at that level is crushing. Temperatures are extreme. Rock behaves less like stone and more like something dense and slow, almost fluid, and yet something down there was moving. Minutes passed. The signal didn't fade. It grew. The waveform thickened, its amplitude rising in smooth, deliberate pulses. Not chaotic, not violent, controlled. As if whatever caused it wasn't breaking, but pushing. A senior analyst zoomed out to a global map overlay. Sensor points lit up one by one, forming a faint ring of detection around the planet. Not random, not scattered. Connected. His voice, when he finally spoke, was barely above a whisper. This isn't local. No one answered, because they all saw it too. The motion wasn't coming from a single fault line or volcanic chamber. It was spreading beneath entire regions, traveling silently. Through layers of earth no human has ever reached. A movement too large to be machinery. Too smooth to be collapse. Too organized to be noise. Another alert flashed. Amplitude increasing. Someone checked the timestamp again. Only 7 minutes had passed since the first reading. 7 minutes. And the signal had already doubled. In the stillness of the control room, surrounded by glowing screens and rising data curves, one realization settled over the team with chilling clarity. Whatever was moving beneath the crust, Big Kern wasn't stopping. Within minutes of the initial detection, the world's most advanced monitoring networks were fully engaged. Deep beneath mountains, inside reinforced vaults, and across remote ocean floors, thousands of seismic stations constantly listen to the planet. These instruments are designed to detect the smallest vibrations, waves generated by earthquakes, volcanic shifts, even distant explosions. Every second, they stream data to research centers where algorithms scan for patterns. Tonight, those algorithms had locked onto something unusual. On massive screens, technicians overlaid live seismic feeds with satellite positioning data. GPS stations, year anchored into bedrock across continents, measure ground movement down to fractions of a millimeter. Normally, tectonic plates drift slowly, almost imperceptibly. But as the incoming data synchronized, scientists noticed subtle displacement readings aligning with the deep signal, not at the surface, far below it. A 3D model of Earth's interior rotated slowly on display. Layers illuminated, crust, upper mantle, transition zone. Analysts began calculating wave travel times, measuring how long vibrations took to reach various stations. That timing revealed depth. The estimate appeared hundreds of kilometers down, too deep for typical earthquakes, too deep for magma chambers. At that level, rock exists under immense pressure, behaving plastically, flowing over geological timescales, not in sudden coordinated pulses. And yet the pulses were there. Every 90 seconds, the waveform rose, then fell, then rose again, rhythmic, calm at first glance, but undeniably deliberate. Researchers cross-referenced volcanic databases, no eruptions, no unusual thermal signatures from satellites. They checked known fault lines, San Andreas, the Pacific Ring of Fire mid-ocean ridges, nothing aligned with the coordinates of the strongest readings. The movement wasn't following plate boundaries, it wasn't clustered beneath hotspots, it was occurring beneath regions long considered geologically stable. That was when unease began to replace curiosity. A senior geophysicist requested archived data from the past decade. If this was natural mantle convection, there would be precursors, subtle hints building over years. Supercomputers compared the new waveform against millions of historical records. No match. The signal's structure was smooth and repeating, almost like a slow heartbeat beneath the crust. Not chaotic like fracturing rock, not explosive like gas release, consistent, too consistent. Live feeds from Japan matched those from Europe within fractions of a second. South American stations confirmed identical depth profiles. Independent networks, operated by different countries, calibrated with different software, were reporting the same pattern. The possibility of instrument error faded. This was global. A satellite gravity map was pulled up next. These instruments measured tiny changes in Earth's gravitational field caused by mass shifting below. As fresh calculations processed, a faint anomaly began to appear. Subtle, but real. Something dense was redistributing itself far beneath the surface. Still no surface tremors, still no visible warning. Above ground, cities slept. Below, something immense was moving with measured persistence. The pulses grew slightly stronger, barely noticeable to an untrained eye, but undeniable in the data. 90 seconds became 88, then 85. The rhythm was accelerating. In laboratories lit by pale screens and reflected worry, scientists faced a quiet, unsettling truth. The movement was real. It was deep. It was organized. And it was happening in places where nothing like this was supposed to happen at all. The room is quieter now, not because the data stopped, but because it didn't. Screens continue to glow in the darkness as scientists monitor the movement in real time. Fresh readings stream in every few seconds. Waveforms update. Depth estimates refine. The pulses continue. Steady, controlled, growing. No alarms are blaring. No headlines are flashing. Yet behind secured networks and encrypted channels, messages are moving fast. Government geological agencies have been notified. International monitoring centers are comparing models. Emergency management officials have been quietly briefed, not with warnings, but with possibilities, contingencies, scenarios, hypotheticals no one expected to discuss tonight. Still, there has been no public announcement, because there is no confirmed threat. Not yet. The data remains incomplete. The movement, while unprecedented, has not triggered surface earthquakes. Volcanoes remain dormant. Cities remain still. To the world above, nothing has changed. But below, the depth calculations shift slightly again. A revised model appears on screen showing a broad zone of motion spreading laterally through the mantle, not fast, not violent, but persistent, like a slow pressure wave traveling through layers that were once thought to move only over centuries. A young analyst overlays a predictive simulation. If the acceleration continues at its current rate, stress redistribution along certain tectonic boundaries could increase. Not today, not tomorrow, but eventually. The word eventually lingers in the air. Another update arrives. The interval between pulses has shortened again. 80 seconds, then 76. No one speaks for a moment, because rhythm implies system, and system implies cause. Is it a deep mantle plume rising from far below? A structural shift along an unknown boundary. A phenomenon never before recorded because humanity has only recently possessed the instruments sensitive enough to detect it. The truth is simple and unsettling. They don't know. On one screen, a global map glows where the small points of light, each representing a listening station. Together they form a quiet web around the planet, humanity's attempt to hear the language of the Earth itself. Tonight, the Earth is speaking in a tone no one recognizes. Senior researchers begin drafting a preliminary report. The language is careful, precise. Words like anomalous, seed ongoing, or under investigation. No speculation, no alarm, because science demands patience. But patience feels fragile when the unknown is growing. Another pulse rises across the monitors, stronger than the last. The waveform swells, it falls and rises again. Whatever force is driving this movement is not chaotic. It is sustained, deliberate, expanding beneath regions once considered stable and unmoving. Above ground, life continues uninterrupted. Traffic lights change. Oceans roll against shorelines. Wind moves through trees. No one feels the slow rearrangement happening hundreds of kilometers below their feet. But the scientists watching know something has shifted, not just within the Earth, but within their understanding of it. For centuries, humanity believed we understood the basic rhythms of our planet. We mapped its plates, modeled its mantle, simulated its stresses. And yet tonight, a new rhythm has emerged, unexplained, unpredicted, unfolding in real time. The latest update refreshes across every screen in the room. The amplitude has increased again. Whatever is moving beneath us is not slowing down. The Earth has always kept secrets. The question is, why is this one starting to wake up now? At 2:17 a.m., seismic monitoring stations across multiple continents detected something unusual deep beneath Earth's crust. The signal wasn't an earthquake, volcanic activity, or equipment failure. It was synchronized, rhythmic, and originating hundreds of kilometers below the surface, far deeper than typical tectonic events. What began as a minor anomaly quickly grew stronger, spreading across global sensor networks in perfect timing. Scientists activated advanced monitoring systems, cross-checking seismic waves, GPS displacement data, satellite gravity readings, and historical records. The results were consistent and deeply unsettling. The movement was too organized to be random, too smooth to be fracturing rock, and occurring in regions not associated with fault lines or volcanic hotspots. Even more concerning, the pulses were accelerating. Government agencies were quietly alerted though no public announcement was made due to the lack of immediate surface impact. Still, experts remain on high alert as models suggest potential long-term stress redistribution along tectonic boundaries. The truth is clear, something massive is shifting deep within the planet. And it isn't slowing down. For the first time, scientists are witnessing a deep Earth phenomenon in real time, one that challenges existing geological understanding and raises a haunting question. What exactly is waking beneath our feet?